Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us move to the next question. Question number 3 of NEET 2014 physics paper. So let us solve question number 3. Students, let us solve the next question, which is question number 3 here. It's talk about a particle is moving such that its position coordinates xy are this, and this is the coordinate in time t equals to 0, and this is the coordinate in time t equals to 2 seconds, and now it is at this position. This is the position at time t equals to 5. In obviously it is moving in xy plane because it has z coordinate 0, and you have to find the average velocity vector. So it is about average velocity vector from t equals to 0 to t equals to 5 seconds. So during this journey of 5 seconds, you have to find the average velocity. The average velocity is by definition it is the total displacement divided by the time taken for the change in the displacement. Now the time is obviously 5 seconds, so during 5 seconds you have to find the displacement. So intermediate positions is not required, that is given to confuse you, because this is not important as you are going to find between 0 and 5. So this intermediate 2 seconds is not important because we are talking about the displacement over 5 seconds. So let me explain graphically so that you will have better understanding of this. Suppose this is the origin, this is my origin, this is the x-axis and this is the y-axis. The particle is here, now going there, now going here. We don't know where it is. I'm not writing the exact coordinate, but somewhere it's changing its position. Its position is 2, 3, its position is 6, 7, and this position is 13 and 14. Okay, this is the when time t equals to 0, and after 2 seconds it is here. Suppose this is time, 2 seconds is here, sorry, this is 0 seconds is here, 2 seconds is here. After 2 seconds it is moving to this position, and t equals to 5 seconds it is here. So from here if I start, or from here anywhere you start, this is what is the situation. It might have gone in any path it might have followed, I don't know, and nobody knows what path it follows. Supposing that it follows this path from here to here, supposing that it follows any arbitrary path from here to here, like that. This is not required, this information is not even required, because we are talking about the displacement velocity vector. It is not about average speed. If in case of average speed, this path is very, very important, without which you can calculate the distance. But because it is a velocity vector and the time interval is given 0 to 5 seconds, 0 to 5, so this is my initial position, this is my final position. This vector is r initial vector, this position vector will be r final vector. What is the displacement? So obviously this is the displacement that is occurring from 0 to 5 seconds. I am interested in this. This vector is the displacement vector, say delta r vector. This is the total displacement in time 0 to 5 seconds. So velocity average during the interval 0 to 5 seconds is given by total displacement as shown in figure divided by the total time taken. Total time is 5 seconds. So here it will be 5 in the denominator, and delta R you have to find and put it there. That is the answer. Obviously it is a vector. It will be a vector quantity. So this you have to find and put it there. Now this is what you have to solve for. Now you can from triangle law of vector addition, you know that this vector plus this vector is this vector. I can write that RF vector RF vector is actually the sum of R initial vector plus delta R vector. So from here I get delta R vector. The delta R vector is actually the final vector, position vector minus the initial position vector. Then we have the number, the coordinates are given. Here the coordinates are given. If the coordinates are given, we know how to write that in vector form. If this number is 2, 3, that means this is 2 and this is 3. So 2 I cap and 3 j cap. So if a point is there and the coordinates are known, then you can write that in vector form. In any coordinate system, if we have a point with suppose coordinate 2, 3, then this position or coordinate can be represented with a vector like this. This is called position vector, and this also can be represented in terms of the components that is given 2 and 3. This is basically 2 is this part, 3 is this part, this is 2, this is 3, so this becomes 2 and 3. So this vector is 2 I cap vector, this vector is 3 j cap vector. So if I add these two vectors, I will get this vector. That means if a point is there whose coordinate is known, then you write 2 I cap and 3 j cap, you add them, that is the position vector. Suppose if I have a point like 2, 3 and minus 1, then that vector can be represented like 2 I cap plus 3 j cap and minus k cap, because this coordinate stands for z axis. So I have the points like 13, 14. So I'll write this vector in vector form. The position vector can be represented in terms of that 13, 14. If this is 13, 14, then this will be 13 I cap and 14 j cap. So it will be 13 I cap and 14 j cap. Minus 2, 3, the point was 2, 3, so it is 2 I cap plus 3 j cap. Now you solve this. This is very simple. 13 minus 2, that is 11 I cap. 14 minus 3, that is 11 j cap. Okay, so that means this is 11 I plus j cap. This is your delta R vector. Now you can see that the average velocity over the time interval 0 to 5 seconds is equal to delta R vector divided by 5. So that means it is 11 5 by 5 I plus j. This is the answer. This should be the answer to this question. If I see the options, that is 1 11 5 here, 11 over 5 I plus j, 11 over 5 I plus j. So this is the right answer. So to this question, fourth option is correct. But let me tell you, if the question was, if I ask you the question to find the average velocity over 0 to 2 seconds, then in that case you have to consider this point as final position and this point as second initial position. So it would have been not 13 minus 2, in this case it would have been 6 minus 2 and 7 minus 3. So in short, this is the process I told you, but in short you have to just take the difference and put it in vector form. So this is the process that I explained you to understand this. Otherwise that is a very shortcut method. Just see the answer, you can get the result. The shortcut method is that you between these 2 points it is asked. The first point is 2 comma 3 time t equals to 0, and second, the last point where we are interested is 13 14 and time t equals to 5. So these are our 2 points. So what you do is you take the difference of the corresponding coordinates. X coordinate, here you take the difference, this comes out to 11. You take the difference, it comes out to 11. So it is 11 I cap plus 11 j cap, that is the delta vector. This is the displacement. The displacement is just the difference. So this is your delta r. And if you know this is your delta r, and the total time is 5 seconds, so divide this by 5, you will get the answer immediately without going for extra. This I explained to you so that you can understand how it is done. Okay, so this is the answer. Thank you.